I'm excited to talk today about how we're using data-centric AI and the Snorkel framework at Comcast to power our voice and conversational interfaces. So let me get started with the presentation. So I'm leading the Comcast Applied AI and Discovery team, and our mission is to delight our customers by connecting them to the moments that matter, either via connectivity or in the entertainment domain. Our team kind of is split into 5 product verticals. One, which I will talk today about, which is voice control, where we want to use voice for all the interactions with our Xfinity systems. But there are also other teams such as content discovery, where we recommend you the right show at the right time. Media analytics, where we analyze all the broadcast content as well as live content that we're distributing. So to extract additional metadata from this data and make it available to other systems to create new interactive experiences or for further insights into how customers are using kind of our streaming services. We also have a team focused on the digital home and the applications of AI inside of it. For example, building algorithms that run on our cameras and to detect if somebody is coming home or if a package gets delivered for you. And then finally, we also work on machine learning and AI for the customer experience, where we're building smart assistants to help our customers, agents, and technicians solve different kind of problems. In addition, we're also responsible for kind of the experimentation platforms at Comcast and our products, the data platforms that kind of underlie all these AI and machine learning applications, as well as our product analytics platforms that make it easier to train, develop, and manage models. And finally, also AI and ML innovation and educational efforts. But let's focus on the use case of data-centric AI for voice. So the voice remote was launched for Comcast in 2015. There are now about 28 million plus remotes in use just on our X1 system alone. And we're receiving about 12 billion plus voice queries from Comcast, Sky, as well as our syndication partners. So that is a lot of data that we need to analyze to kind of improve the models that power a voice remote. But so how does it actually work? So if you take the voice remote, you see this blue button in the middle, you press, we then stream the audio to our speech recognition system, where we then translate the sound into a text query. Once we have the text query, we then have multiple machine learning models that translate the raw text into an intent, and then also identify what is the right action that you as the customer would like to accomplish. And then once we identify the most likely solution, we basically execute it. So send like the result to the set-top box and make it appear on the TV screen. So in this case, like all the latest news about artificial intelligence. So how do we understand the intent? Like you can really think about intent as a translation of, as I mentioned, the lexical query using NLP technologies to understand the semantics of that query, which is the intent, and then translating it into a business action. In this case, specifically, we are focusing on the query to intent portion. So one of the challenges we have is that the customers use many different expressions to express the same intent. So if you want to tune to CNN, you could say tune to CNN please. You can say watch CNN right now, or even kind of very colloquially, yo, CNN. Each time, no matter what you say, ideally the output should be an intent of a tune, right? That kind of represents the core meaning. And then a set of parameters, in this case, CNN as the name of the channel you want to tune to, right? That kind of complete all the information necessary to then identify the correct business action. There's also other examples. So for example, here, if the customer says free comedy movies, free funny films, or even uses a different language to ask for essentially just browsing for movies that are free, that are kind of the genre comedy and that are of the type movies. And so you can imagine that this is not an easy problem. So what are some of the reasons why this is difficult? Many of the queries that we have to process are short, and they're very diverse, and we have to refer to many different entities. So in our catalogs, we have millions of entities, and hundreds of thousands are often added every single day, and they change. There's a lot of ambiguity. Chicago Fire is both a TV show and a sports team. Which one are you referring to? Often our customers don't remember exactly what the correct title of a given show is. So for example, they might say for the show Little Big Lies, they ask for Big Little Lies or Little Big something. We have multiple kind of like a sequel or the original movie. People will still just ask for Princess Diaries. So which one should we return? Another issue is that on the TV, there's only limited ways where you can kind of back up to typing in the search because you don't have a keyboard readily available that allows you to input your search. And often we don't have also kind of the type of personalization is often more limited because the TV is often a shared living room device rather than your phone where we know that it's like if you're using it, it's you. And finally, we also, speech recognition can be very tricky. For example, to distinguish between you versus Caillou, it's very difficult for an automatic system. So how do we solve these problems? For the models, we're using kind of what is very popular, kind of a combination of encoder-decoder pattern as well as transformers. So the basic idea here is that you take the sentence, tune to CNN, please. You encode using word embeddings each of these words into a vector. And then the query encoder takes these individual vectors and accumulates them together to kind of capture the meaning of the query. We then train our intent decoder that essentially translates that query into the intent representation. So in this case, as we indicated earlier, kind of a tune, and then the parameter with the value CNN. So to train these models, we need a lot of data. So one way you can train it is using synthetic examples. Given that many of our queries are short, domain experts are able to write rules kind of in template form that allow us to capture a number of the intents even without deep learning. So for example, show me all genre on channel should be translated to the browse genre and channel information. And now with these placeholders, we can use our metadata database and insert various kind of forms, be it like synonyms, for example, for the genre, as well as all the different channels. And by kind of creating a lot of this synthetic data, we can now train deep learning models that are able to handle both these relatively simple use cases as well as more complex use cases. At the same time, this is not exhaustive, right? I mentioned also that we are receiving millions of queries every single day. So it is not possible to annotate and verify that we capture all these patterns. So we have to do some automatic training. So how can we do that? And I want to kind of use one example that is a real example from our production logs where we noticed that a number of people were asking us how to commit a murder, which is not something where I hope, like as a system, we have a good answer for. So what are the customers are actually trying to accomplish here, assuming positive intent? So what we then saw is when we looked at kind of overall usage logs is that once like our system did not return the desired answer, which was a TV show, they actually went into our interface and kind of were able to navigate to the How to Get Away with Murder show on demand. Right? Similarly, we saw with other folks for the same query that they then used another query called, in this case, ABC, and then watched the show How to Get Away with Murder. So what this allows us to do now is, if we're looking at our session logs, we can identify weakly labeled examples that we can then use to augment our training of our NLP models. So to do this weak labeling, we use what we call our automatic labeling framework. So we combine our NLP speech logs, the logs from the user interface of how our customers are navigating through our interface. We use a session builder to create then these kind of temporally aligned session for our customers. And then we use the Snorkel framework with its labeling functions to weakly label the data. And then using that generative model, we can now apply it to a number of use cases for our system. So if the easy way is that we can use it to identify positive and negative exemplars for our speech transcriptions. When did our speech system actually perform accurately, and when does it not? We can also predict the user experience. Basically, we track what we call the negative interaction score, which is if you are making a query and you're not watching something very soon after, then we probably didn't understand you correctly, right? Or if you have to repeat queries. So in this case, if we see a query of that where the customer wanted to say Telemundo, but we captured only the mundo from the speech recognition, then we would kind of basically use a negative label and assume we had a negative experience. Also, similarly, we can identify incorrect transcriptions, truncations, etc. For example, when dashing through the snow, and the suggestion crashing through the snow when you kind of said it again would allow us to identify an error type. And finally, we also we are not using any guard words in our system, so sometimes we predict that kind of the domain for a query is incorrectly identified. So instead of it being a TV query, if you're asking who's the president of the USA, we won't have an answer for you in the TV domain. So instead, it should have been going to the general knowledge domain and answered there. And so we can then identify what we have to improve in our domain classifier so that the mapping from the query to the domain is done correctly. So let's take a look at some of these sessions in detail. So here's an example where we started out, the first interaction was a voice query, which we transcribed and understood as gorilla. And then the customer pressed exit to start over. And then they said the query again, and this time we got Cruella. And then we see the customer navigating, entering, which is sweet, and followed by a tune to actually watch something which we can interpret as a positive interaction, at least after Cruella, right? But we know that gorilla was not working out as planned. Similarly, if you kind of navigated after that and then said, what's a Gorilla Deville, and navigated again, and finally you were able to get to Cruella on Disney Plus, and said that again, we know that our previous recognitions again were incorrect, and the app launch for within Disney Plus, kind of we see that we were actually not linking to the correct show directly and forcing you to go into the app and find it yourself there, which is a negative outcome. So if we kind of, what are now some of the labeling functions that we came up with? Kind of a positive label is if the query was actually completed, as I mentioned, with one of these following actions. So if I have a query followed by a tune, an app, a play, or kind of a volume change, we label it as positive. If a query is followed kind of with a text search, so instead of using voice, you actually type it into a search interface, you use the menu, the TV, linear guide, or kind of a channel selection, then, and we did not take you there directly, then we probably got it wrong and we used it as a negative example. If queries are repeated, then kind of depending on how these two queries relate, we would, if they're the same query or very similar queries, then the first one would be labeled as negative, right? If they are the same, if the second query was done, then the second one would be neutral, different, right? If we go into an app, so you give up on us finding the show, but you know where, on which app it is, then we would label that as negative. And if you're, instead of looking for the show, you can now change it to another entity, like an actor or something, then we don't quite know how to handle that. And then also, like if you say a query and then you navigate after that, that at least we interpret that as getting you closer to the right outcome and label that as a positive sign. So how are we actually now integrating this into our voice architecture? I mentioned that in the beginning that we use a combination of kind of a speech and kind of natural language understanding components to understand what you're saying on the voice remote, but that is not enough. I already mentioned that we need a lot of training data to train deep learning models. So we need to kind of create data that we can then feed into our training algorithms, right? So it could be the raw data, but it's also like the training data labels, business logic and overrides, as well as ontologies that need to be input. And that data can come from kind of external data stores. We have a central metadata service where we get, for example, our information about potential entities that we can search for in our system. We have the voice annotation UI where you can manually annotate kind of what the right interpretations of queries are. We have a content management system where we can create additional content that we might want to show. And then we also have explicit tests via QA where we can verify what kind of, if our models behave correctly. And so now what we did is we basically added this automatic labeling framework as an additional input into this data store, where we take our production events as described, use the ALF framework to create the weak and self-supervised labels, and thereby augment our overall system. So why do we kind of go through all that trouble? Like, you could probably build a much simpler system if you're content with only doing exact matches, which a lot of the systems in the market currently do, right? So you could match to the exact titles for movies and episodes, or you could only like basically match against like only a fixed set of metadata tags, such as comedies, horror shows, etc. But we're not satisfied with that. Like, what we really envision for a voice remote is for you to be able to ask us anything and we will show you like relevant results. So for example, you should be able to ask movies about any place in the world, movies about certain people, even if they're not actors. You should be able to ask for shows about concepts such as climate change. And we should basically be able to return semantically meaningful results for you. Also, it's often hard to remember titles exactly, especially of episodes. I never know what the title of an episode was, but I very well know what happened in it that made me remember it. And so if I can just describe what happened in the episode and it will bring up the correct one, that is very powerful. And as we're evolving into more conversational interactions with our devices, like, we truly need to get to that level of semantic understanding that is necessary, and automatic training is essential to make this possible. So I hope this was helpful for you. If you would like to learn more about what our team is doing, both on the voice side and in our other domains, please check us out on our team page. And it was a privilege being able to present this to you, and I'm looking forward to any questions you might have. Thank you so much.
Jan, thanks so much for that presentation, and thanks so much for joining me for a live Q&A now.
You're very welcome. Looking forward to your questions.
So yeah, looks like the audience, has a few questions. We'll go from the top. The first question we have is, how do you analyze journeys with greater than 10 and still find associations from happy, not so happy paths?
with greater than 10 steps, I assume.
I imagine that's what it's asking, yeah.
Yeah, so I
Not sure
mean,
if
the
there's
way
a
we're thinking about
clarification.
it is that we're taking all the voice sessions, UX interactions, and then sessionize them together. So the length is really not a problem. Mostly what we're using is breaks between interactions to kind of group different sessions together. So there's no hard length to each of the interactions.
Okay. So the next question from Vashisht is, how does this process scale as new TV shows, labels, are added continuously? Do we adapt the model for this one class or retrain the entire model?
We continuously update. So the way we do it is in a multi-step process. So one is that we identify the kind of, as I described in the beginning, the intent plus parameters. So we can identify parameters even if we don't necessarily know about them, just by their position kind of in the query itself. And then we interface with our content discovery solution to send then that name of the show in this case to our search system, which will then return results. And that gets updated as soon as new entries get added to our catalog. So that happens throughout the day, pretty much within a few hours after they basically get submitted to us by our partners.
That's awesome. The next question we have is from Joydeep. You mentioned query encoder and intent decoder. Are you using common large language models like BERT or GPT-3 or full transformer models like T5?
So currently our model is an adaptation of the BERT model. So we did not see the use of we're currently exploring the use of larger language models, such as GPT-3 and similar versions. Though for our use case, where the domain, since we're focusing on the entertainment domain, the range of speech is somewhat limited, also because our queries are relatively short as they're spoken into kind of as commands usually. We did not necessarily need the larger language models, though, as I mentioned, that as we're expanding into more conversations, where we want to look at the whole conversation and also take prior context into account for the resolution, we are exploring kind of the use of GPT-3 and other larger language models for that use case.
That's very helpful. The next question is, could you speak a little bit to the data infrastructure? How are we getting deeper tags and semantics about TV shows and movies like content and metadata?
So we use multiple sources. So on one hand, we built an internal metadata store that includes ingesting information from various partners. So it could be directly from kind of our app partners. It could be from some of the Rovi or Gracenote that provide TV metadata to us. That is usually at the show level. I mentioned in the beginning that we also have an internal team that focuses on media analytics, where they analyze videos to get scene level metadata. So who's on screen when, what are they talking about? And they can provide us with more detailed analysis of what's going on in a show, music analysis, themes, emotions, that we can kind of incorporate into our queries.
Great. We have a question that just came in about how do you manage intent conflicts as you scale?
So the part of it, we are validating kind of how our intent classification, or if the correct intent was recognized by seeing how the customer reacts towards it. Part of like the goal of the identifying negative interactions, as I kind of called them here, is to also then forward them to our annotation team and add new intents as necessary to the kind of models, and so that we can basically add them as training data.
The last one is less of a data science question and more just of a how do we connect with what's going on at Comcast? Joydeep is asking, what's the website to connect and see what's going on with your team and at Comcast at large?
Probably the easiest way to kind of find the web page is just to look me up on LinkedIn. I have it in my profile. And
Awesome.
we are always looking for people to want to learn more about us, and I'm happy to chat.
Awesome. Thanks so much, Jan. Thank you for the presentation. Thank you for answering these questions and just being here with us today. We really, really appreciate it.
Yeah, thanks for giving me the opportunity. And
Of course.
enjoyed it.